Alrighty, let's see. Total waviness of numbers in range, part 1, medium. We're given two integers, num1 and num2, representing inclusive range, num1 to num2. The waviness of a number is defined as the total count of its peaks and valleys. A digit is peak if it's strictly greater than both of its immediate neighbors. A valley is strictly less. Okay. The first and last digit of a number cannot be peak or valley. Okay. Any number with fewer than 3 digits has a waviness of 0. Any number with fewer than 3 digits. Okay. The waviness of the number. Okay, so you're actually looking at the numbers themselves, not the, like, you're looking at the digits of the numbers. So each number itself is a waviness. Okay, so 1, 2, 1, I think that counts as a peak, right? 1 is strictly less than 2, which is also 0 is strictly less than 2, so it's a peak. And 1, 3, 0. Oh, this is a peak, and then I have to do all the numbers between them. 1, 2, 1 is a peak. 1, 2, 2 is not. 1, 2, 3 is not. 1, 2, 4 is not. I see. So the waviness is the total count of its peaks and valleys. Oh, jeez. And these things probably can go multiple digits up to 5, I guess 4 digits, right? Because 10 to the 5th is just going to be non-wavy, and then below that's 4 digits. Okay, this is one of the ones where you can use the pre-compute, which will probably optimize the answer, but strictly speaking, you should be able to do the answer without pre-computing. So yeah. All right. What to do here? What 8, 4, 8. All right, so let's go ahead and try. So let's say 1, 2, 1, 2. Or let's say 1, 2, 1, 0. Up to 1, 2, 3, 4. It's arbitrary. So if I do the strict subtraction, it's there's 24 numbers. Okay, yeah. 25 numbers inclusive of the last one. And then I need to count the number of waviness of all those numbers. So 1, 2, 1, 0. If I make that into an array of digits, well, I don't want to think about this as counting, maybe. I want to think of this as maybe a backtracking situation. Maybe a backtracking situation. If I want to do the counts, I never really cared about having the next digit be the same as the previous digit. It has to be strictly different, either less or more. So it's 1, 0, 1, 2. And then if it's less, then it has to go bigger, and if it's more, then it has to go smaller. So the direction of change has to be different. So the backtracking has like the index. Thinking a backtracking function that has the index that you're dealing with and maybe like whether or not it's going to try to go upwards or downwards from there. And it might have some sort of upper bound for am I really going to recurse through every single possibility? If I recurse through every possibility, it is going to be O of n, where n is basically up to 10 to the fifth, or the difference between the low and the high. Oh boy. Like a backtracking function. What if it was like 3 digits to 4 digits? Then I would probably make this thing to a 4-digit array. Yeah, I'd probably make it into a 4-digit array. I think I'm going to do something weird and say that if num2 equals 9999, then num equals 10 to the fifth. I'm just going to make it 9999. Yeah, I think I want to do 4-digit array and then have something where the array starts with the first digit that's not the same. The first digit's not the same, so for instance, if it's 1210 to 1234, then the backtracking array starts with 12. Maybe it starts with 121. I guess the backtracking array should start with 1210. How should this be done? It should start with the first thing that's not common. Maybe something like that. And then if it's 0121, it should start with maybe that. The 0 and 1 are not common. No. Why doesn't it just start with the... I don't want the backtracking array to somehow prevent itself from going out of bounds, but maybe that's just too semicolons. Yeah, maybe this is just, maybe I'm overcomplicating this. I think maybe I should just basically figure it out for every single possibility. And then there's like an easier way of doing this, or not easier. There's a more straightforward way of doing this, and then there's optimizations that I'm trying to jump to. Okay, let's just do the backtracking function. So backtracking function is going to be, it's going to have, I want to say current value. Like there's an array that I want to mess with, but then there's also a current value of the 4 digits in the array. So I'll have a value, maybe the array is actually global. I guess it might have an index. Oh, whoops, making Java here. Values int index. And so backtracking is basically recursion, or a form of recursion. So I always do base case first, which is when it has 4 digits in the array. So if the index is equal to 4, then the values, let's say there's an answer count. I guess I definitely need more than this one. It needs to have the wave count here. Maybe it's just called waves. And it needs to have like a marker to denote whether or not it's going up or down. It's strictly greater than its neighbor. Is up. It won't, for a base case where it reaches the 4th digit, it's not going to really matter if it's swing going up or down from the previous digits. So it's just like, and if this value is between the num1 and num2, answer equals the number, answer increased by the number of waves. Otherwise, answer doesn't increase. And then regardless, return from there. I don't think this actually, does this work? I don't know if I can use answer in this fashion. It's kind of like global. Let's say the value is 1212 waves is 2 here, is up is false. Actually, it's true. Index is now 4. Oops, I need to change some stuff. Nums1 is not defined. Test case 1212 to 1212. Yeah, I can't do this local variable bullshit. I think the easiest way here is to make this an instance. And then make this an instance variable. Okay, it says 3. Why did it put 3 here? What? All answer equals 0. Backtrack 1, 2, 1, 2, 2 waves, false, or true. Index equals 4, which it is. Oh my god, I'm an idiot. Current value is between nums1 and num2. Still not sure why this is 3. So is it calling back multiple times? Why would we call multiple times? Oh no, sorry, the output is 0. The expect answer was 3. Oops. Oh boy. Okay. So the base case here was when digits array is filled. I'll go array is equal to, I'm not sure if it's just all zeros. Not sure if it should be all zeros. Or maybe it just should start with a single digit. Maybe it should start just with a single digit. That is at the very let's see. Crap. So I think it needs to actually be is up, or needs to be like change, and the change is either going to be so for backtrack, kind of recursive function, value is going to be 4-digit value of array, e.g. if the array is like 1, 2, 3, 4, value is equal to 1234. Waves is the count of peaks and valleys up to in the val. So if it's 1, 2, 3, 4, then well, let's do something. It's 1, 2, 3, 1, 2, 2, 1. No. 1, 2, 3, 1. Then it's going to be 1 peak. Change is equal to the last kind of increase or decrease, last delta. So if it's like increasing, then it's going to be +1. Any decreasing is going to be -1, and then same is going to be 0. So the last delta between the last two digits of the value. And then index is place index, or length of the array, the digits array. Okay. There's better ways of starting than just 0, but whatever, I think it's fine. So backtrack starting with value 0, and the weight is 0, change is 0, and index is there should be, maybe it should actually be empty. Yeah, if it's empty, then it's really bad. If it's empty, then it really doesn't work. Then if it's not empty, then what is it going to be? Index 0? Something like that. Array is empty. No, I guess maybe I actually do need something like for every okay, so I think what I want is I did delete the nums2 equals 9,999. What happened to that? If nums2 equals 999, go low start digit is equal to well, should be num2. Low start digit is going to be num1, divided into, is it, it's 10 to the third, 10 to the fourth. My start digit is going to be num2 divided by that. Yeah, there's better ways of doing this, but I think this should work. So I'm going to have an array that starts with the first digit in the range of this. So let's say for every digit in range of the low start digit to the high start digit plus 1. So it includes the last value. Array starts with D. And then do the backtrack. Okay, so backtrack, so 0, the value should be D. The number of waves is 0, change is 0 because there's no, it's the same. And the index that I'm going to deal with now is index 1. So index, deal with index 1, deal with index 2, deal with index 3, and then deal with index 4 after it. Okay. I think that's the setup. And then I just need to do the recursion. Just do the recursion as if it's the hardest part. So here it should be for every digit in range 0 to 10. 0, 9 inclusive. Let's see. I need to do some logic to update the number of waves based on the last digit, current digit D, and the change. So if the change is going downwards, maybe I should just do maybe I should have an outer logic loop. Maybe there should be an outer if statement if the change is previously going up, or if the change is previously going down. Let's see how that looks. Change is previously going up. So that means that I need to be below the last digit. in order for it to be an increase in the peak, or yeah, to increase the peaks. And if it's above, then it's not. The best way of doing this. Upwards, then for every D in range from 0 up to the last thing. D from 0 up to the last thing, which is going to be array -1. Yeah. Then this is going to be backtrack. The value is going to be value times 10 plus D. The number of ways is going to increase. The change is now downwards. And the index is now index plus 1. Okay. So it's going upwards, and now D is less than the previous last digit. So like if it's going like 1 to 2, and now D is either 0 or 1, it's going downwards, form a peak. And then there's going to just be a singleton for no change. Backtrack, value times 10 plus the last digit again. And yeah, actually add this to the array, don't I? It's a backtracking array. Well, do I even need to? I don't actually need to keep the array, do I? I just need to keep the value itself. Okay, I see. The array is just not necessary, it's just the value in the array. So value is 4 digits. But I do need the last value. I can calculate that manually or can pass that through. I think I can just pass that through. Yeah, rather than recalculate it each time. I mean, I guess it's not that big a deal to recalculate versus pass it through. Okay. So this is up for D, up to the last digit. Value times 10 plus D. The last digit is now D. What is this one? Minus 1, okay. Otherwise, called backtracking, value times 10 plus the last digit. The last digit waves does not increase because it's the same digit repeated. The change factor or the change variable is going to be 0. Index is now index plus 1. And then for D in range, from the last digit up to 10, backtrack, value times 10 plus D. So now it's still increasing. So waves doesn't increase, still increasing. as the change variable. Else if the change value is 0, the logic is going to be very similar. Logic is going to be very similar, it's going to be almost identical. So I probably should figure out what the right formula is here. Let me just write it out, and then maybe I can figure out the formula easier. So it doesn't really matter, but it's here. It's going to be value times 10 plus d. Last digit still d. Waves is not going to change, and it's decreasing here. Well, value times 10 plus d. Oh no, this should be last digit. So last digit is going to repeat. The number of waves is the same, 0 as the change factor, and then for d in range, last digit to 10, value times 10 plus d, d waves. Now this is increasing. And then else, so here's for change is decreasing. For d in range, last digit. I should just do copy paste, to be honest. So this is where it's deep below this decreasing. If it's already decreasing, then the waves doesn't change. And then this is where it's the same. This is where it's increasing, which in this case will make for a valley. Okay, so what is the generalization of these three cases? So the for loops and single statement for repeats is the same. Index increases. The next thing is always going to be value times 10 plus d, where d is the last digit. Where's the new current last digit? Still going to give you -1 or 1 for increasing or decreasing. And it's just dependent on how it's going to increase the wave count, if at all. Increase the wave count, if at all. So I think this wave count is increasing when the change is positive and going downwards. Let's go ahead and just make a chart here. Change. So if it's 1, 0, so this is the last change. and this is the current change, and this is the wave increment. I guess this is a 3 by 3 or 3 times 3. So if the last change is 1, and the current change is -1, then this should give an increase. Last change is 1, current change is 0. This is no change in the number of waves. Last change is 1, current change is 1. And this is just all zeros. Sorry, current change here is -1. Maybe I should be better about this. Current change is -1. Current change is 0. Last change is -1. Okay, so what's the formula here? Oh, there should be 0. If they multiply to 1, so I can do their multiplication. Their multiplication can be 1. One XOR -1. Last change XOR current change. But 1 XOR 0, it's going to not work. So if I can do their multiplication, if their multiplication is +1, actually if their multiplication is -1, I see, if their multiplication is -1, then that's the change. If the multiplication is +1, then that becomes 0. So 1 times -1 is -1, 1 times 1 is 1. But I want to map -1 to become 1. I want to map 1 to become 0. So if I can do like negative of the multiplication, if I do the negative of the multiplication, then this is going to become +1. This means -1 times 2. One -1 to 1. And multiply it times 2. Doesn't work. If I shift it, if I add, if I subtract 1 from it, it becomes -2 to -2 and 0. If I do 2 minus the value, I need to shift it. It becomes 0, 2. No, I need to shift it downwards, so it becomes -2 and 0. And then divide by -2. Interesting. So this is the expanded logic. I should probably test this before coming up with some wild simplified logic. I think this is going to be right. Okay, yeah. So this should be I'll call it the increment is equal to say the last change. So let's change. So this is increase, this is decreasing. Change times -1. What if I made this +1? If the last change is decreasing, the last change is increasing, and this changes. I think that I'm going to make this +1. And then times 2, no, then add 1. Plus 1 divided by 2. Okay, so if this is decreasing and current, if the last change is the last change is right now it's below. The last change is increasing. Last change is increasing. This change is 1. For d less than the last digit, that means it's decreasing. 1 times 1 plus 1 times 1 is 1 plus 1 is 2 divided by 2 is 1. But if the last change was decreasing, it's -1 plus 1, or -1 plus 1, yes, 0, 0, 2, 0. So it's, yeah, okay. I think that's right. Backtrack value times 10 plus d waves plus the incrementing here is decreasing. Current change is decreasing. Backtrack value times 10 plus the last digit. Last digit is repeating, waves is repeating. And then for every digit greater than the last digit, incrementing is change times -1 plus 1 divided by 2. Backtrack value times 10 plus d waves plus increment is increasing this one, index plus 1. I think that might be it. Am I missing anything? Missing the self. Oops. Since I made it instant function. Oops. Mislabeled that ink. Oh boy. I was giving some outputs. 8, 0. Yes, I can just print out what the 8 values are here. Print the current value and the current number of waves. Okay. 198. 200 is 1. Oh boy. Hmm. 200 is 1. 200. Oh, mother. That's right. I'm counting it too early. The number of waves doesn't start until the third digit, right? The number of waves doesn't start until the third digit. Maybe I need to actually start the number of waves at a negative number. So if maybe I just need to have an index. So it goes up, increases. 198. Actually, I'm not sure. It goes down and then up. Actually, wait, what's happening here? So uh, 0 goes to 1. And 0 goes to 1. I mean, that's correct. 2 goes to 0 to 0. It's not correct. 2 goes to 0 is decreasing. But then 0 goes to 0 is not increasing. Shouldn't be increasing the number of waves there. Goes to 0 to 0. So it starts at 0. Oh, I see. Yeah. It's actually treating it as it's treating it as 0, 2, 0, 0. Actually, I'm not sure why this is repeating it twice. It's treating it 0, 2, 0, 0. So the first yeah, 0, 2, 0, 0. I guess. Interesting. I guess I don't need to quantify. So if I start out at a what number should I be starting out with? I should probably start with a digit 1. This is going to be a slight rework. Digit 1. Maybe I just need to rework this. Maybe I just need to go 1 through 9. So I just don't have the first value in the array. It's actually D. In that case, the base case is I think here it's actually going to be something like if the value, if num1, let's make it to value, let's make it to nums2, then self.answer plus equals the number of waves in this number. And then also stop if the value itself is bigger than nums2, greater than or equal to nums2. Or I guess if it has the for the number of digits in the total digits is going to be nums2 log of nums2. The fastest way to find number of digits in a number Python. What is it? Math log 10. Integer of math log 10, absolute value of n plus 1. Okay, so it's going to be integer math log 10 of nums2 plus 1. Right. I don't need to worry about absolute value. Okay, so if it's bigger than if it's at the index of the total digits, I think I need a break as well, or return. This is inclusive, I need to keep on going if it is. If value 1, 2, 3, 4, 5, 6, 7, 8, 9 with value is if index is equal to total digits, then return. So this is the actual base case. Given that I'm not no longer using the array, no longer having it filled with zeros at the front because that changes the count. Okay, let's see how this, does this actually compile? Alright, it's closer. Okay, so 1, 2, 0, 1, 2, 1 is not counting. No, it's actually counting those right. 1, 2, 0 is 1 peak, 1, 2, 1 is 1 peak. How did it get 3? Oh, 1, 3, 0 is a peak, yeah. I'm not sure why there's 2, 2, there's 200 twice. Why is there 200 twice? 2 zeros, 0. There's twice and it has the wrong count of the number of waves and the second time it appears. Then what is wrong with this actually? Yeah, it's just that time. Am I... Oh my god, I'm an idiot. It's supposed to be last digit plus 1. Okay. Is that it? Oh. Oh, this is bigger than I expected. 10 to the 5th is 100,000. My bad. Yeah, this is gonna be this. Well, answer, let's try this one. Test case. Oh, it's so slow. Yeah, it's so slow. Well, we'll see. It's probably too slow. Yeah, it is pretty darn slow. But it can be optimized, I think. Can it be optimized? One, two. I guess it should be the 5. 1, 2, 3. 10 to the 5th. I guess it should be like up to 4 digits. Values is the actual value of the number. And then last digit is the last digit. Here's the ones digit. Wave count of the number of waves in value. So it's 1, 2, 3, 1. The minimum waves is 1. Number of peaks and valleys. Change is less delta. Index is the length of the number of digits. Index equals total digits. I think that's right. Okay. Guess this thing probably doesn't need to calculate each loop, huh? Okay. That might speed it up just a bit. Not really. Not really. Same speed. Guess I don't need to do recursion here, to be honest. Yeah, I could probably do this without recursion. Probably somehow deal with some sort of for loops. Outer loop is like the outer loop is some sort of incrementing value. Inner loop is that right? Technically this is nested for loops for each level of recursion, so I had to flatten it out differently than that. Otherwise I'd have like up to 5 loops. Up to 5 nested loops. I mean, theoretically I can probably type that. Recurse. Hmm. 30 milliseconds. I can also try to pre-compute this stuff. But then I wouldn't. I'd have to change it so that it doesn't actually go from 1 digit 1 all the way up to 5 digit 999. Have to store the info, have it only recurse through valid numbers. Oh my god. It's really bad. Really bad. And just move this out. This is kind of work. Logic relating calculation of number of waves. Index equals total digits, skip. Increase. Same, decrease. Oh. Would probably be all right. I'm too tired. I'm too tired, and also I don't know if I have it in me to know what the answer is. I guess maybe this other stuff was kind of useful. Wow, is this just poor padding? I'll say this is last change. Current and wave increment. Let's type this again. Last change, current, last change, current. Last change is 0, current is -1. This is all 0 for the increment. Last change is -1. I think the formula that I came up with was negative of last times current plus 1 divided by 2. So summary here. Unfortunately, came up with a rather unoptimized solution, or strictly inefficient solution, using backtracking. Ideally, it doesn't use recursion and uses some form of pre-computation to cut down how much it needs to compute, probably down to like a factor of 10 at least. I guess factor of 100 looks like. For backtracking, had a value at, well, backtracking, well, call function using the above parameters. Each function call appends another digit, as well as tracks the number of waves in the current value and whether the last two digits are increasing, decreasing, or same in the change parameter. So yeah. Increases the count and returns from the function using appropriate logic. So if the values ever between the nums1 and nums2, then increment the count by the number of waves, and then if the number of digits is net in nums2, so if nums2 is like a 4-digit number and this thing is 4 digits, then adding another digit is never going to work, so it's going to return them. Complexity of n, where n is the range of values. So in this case, it's O of 10 to the 5th. Basically, it's O of log of n, since that has up to digits of calls at any time. Okay.